Hello guys, I hope you are well. I hope you're well. So I just remembered that last time I gave you something to solve and you didn't get back to me. Didn't tell me what the answer was. Because I remember I asked you to solve something that this was under the video. So I won't do it and I can't assume that you got it correct or wrong because you didn't even get back to me. Right? I asked you to solve this. So please solve this and get back to me because I'm 100% sure that you'll get this in your test, in one of your tests, if not your exam. So please solve that and get back to me, please, guys. So another thing, today we'll be doing solving set equations. We'll be solving set equations. So I might finish this video might be short because we'll be doing this also on the next chapter. So this is the end of chapter 1, right? In the next chapter, it's about equations and inequalities. So hence I'm saying we'll do this again. But here we are solving them, we are solving set equations, right? So in the next chapter, it will be all the equations, including quadratic and everything, and the inequalities as well. But here we are only solving equations that have sets, and I must tell you that this is very, very important because these are the most type of equations that they will bring because it's something that you learned this year, right? It's not like the quadratic equations that you've known since from grade 9, right? So you must understand how to approach the equations. And what I will tell you is that always keep your variables to the left hand side. Always keep your variables to the left hand side, right? And then meaning that if there's any coefficient, start by dividing that coefficient on both sides, right? You eliminate that coefficient by dividing on both sides, right? And then if that particular set can be written as a fraction, do that, express it in the form of a fraction, right? Express it in form of a fraction, right? And then you solve, right? So just to recap, remember that if you're given something like x to the power of 4, this is the same as x to the power of 4 all over 2, because we have an invisible 2, then we know that this is the same as x to the power of 2, because 4 divided by 2 is 2, right? So just remember this, right? That if you have 3x to the power of 4, this is the same as 3x to the power of 4 over 2, right? Which would be the same as 3 x to the power of 2, right? I hope that makes sense and I'm not confusing you guys. It's that simple. It's that simple. Don't overcomplicate things, right? It's that simple. So when it comes to solving sets, it will be simple, right? It will be simple. So let's start with our first example, right? Because it's best when I'm writing these things down. So let's assume that they give you, so to conclude, the first thing would be to write it in an exponential form, to write each set in an exponential. But first, obviously, you have to ensure that the variable is on the left-hand side, right? So the first step is ensuring that the variable is on the left-hand side, right? That's the first step. The second thing would be to write it in exponential form. And the third thing to do would be to divide both sides of the equation with a coefficient if there is. If it's only 1, you don't have to divide by 1, right? So you divide both sides with coefficient. And then the fourth thing to do would be to simplify the exponents, right? I think if I'm writing them down for you, that will make things easier to follow these steps, right? And then The last thing to do would be to check the solution by substituting the answer back in the original equation, right? So I'll just say check by substituting, right? So let's say the first example, let's say you're given something like 5 x to the power of 4, and then it's a cube root. Okay? So given 5 cube root of x to the power of 4, right? And you're told that this is equal to 405. Then you're asked to solve for x. So the first thing that we have to do is ensure that the variable is on the left hand side. So we can see we are solving for x and x is on the left hand side. So we're done with that step. The second thing to do would be to write it in an exponential form. So I just showed you that you take the coefficient and then you write this x to the power of 4 all over 3, because it's always the exponent all over the degree, right? It's always like that. So it's, but what do you call 4 to the power of 4 all over 3, right? It's 4 all over 3, right? This is equal to 405. So we've written it in an exponential form. The third thing to do would be, the next thing to do would be to divide both sides with the coefficient. So we have to divide both sides with 5, and we can see that this is divisible by 5, right? We can see that this is divisible by 5 because the last digit is 5. So when we divide 405 with 5, I think we'll get something like 81, right? So you'll get 81, and obviously you have to show that you're dividing by 5, right? You have to show that you're dividing by 5 on both sides, right? So this would cancel that, and then you'll be left with x to the power of 4 all over 3, right? So we've divided, and then the next thing to do would be to simplify the exponents, right? The next thing to do would be to simplify the exponents. But in this case, the easiest thing to do is to ensure that you also write this in an exponential form, right? So this in an exponential form, you go to your calculator, you type in 81, you go to equal to, you click shift, then you go to that button which is fact on top, it's written fact, and that should give you something like 3 to the power of 4. It should give you something like 3 to the power of 4. So now from here, then we go to this step of simplifying the exponents, right? So how do we simplify the exponents? You take, we want to solve for x, right? So if we want to be left with x here, we have to eliminate that 4 over 3. How can we eliminate it? We can eliminate it by writing the inverse of it, right? So we take 4 over 3, we swap it to 3 over 4, because this and this will cancel, and this will, and that will cancel, so we'll be left with 1, right? So, but in maths, you know what to do on the left hand side, you must do on the right hand side, right? So we take that x to the power of 4 all over 3, we multiply it with 3 all over 4. Why are we doing that? To eliminate this. If it was 1 over 2, we'd multiply it with 2 over 1, right? So we just swap the numerator and the denominator. So what we did here, since we multiplied with 3 over 4, we also have to multiply this side with 3 over 4. So we have to multiply this side with 3 over 4, right? So we know that this side will cancel and we'll be left with x. But this side is 4 multiplied by 3, which gives you 12, and 12 divided by 4, that is 3, right? So you'll be having 3 to the power of 3, right? And then you know that x will be 27, because 3 to the power of 3 is 27, right? It's that simple, guys. I hope I'm not confusing you, right? It's that simple. That is how you approach these things, right? So now that we've simplified, we have to check answer by substituting. I don't have a calculator with me, but I'm pretty sure that if you substitute 27 there, you would get 405, right? So that's how you approach these things. It's that simple, right? So I won't write these steps down. You can write them down and keep them as the video continues so that you mark each step, right? I just wanted to show you the approach. So let's assume that the next example, we are given something like, let's say x minus 4 root x and plus 3. And you're told that that is equal to 0. And obviously you're asked to solve for x, right? So the first thing to do is to ensure that the variables are on the left hand side, right? So we have that already. And then the next thing to do would be to write it in an exponential form, right? To write it in an exponential form, right? So simply would be having something like x minus 4x, and then we have invisible 1 day, we have invisible 2 day. So this is the same as x to the power of 1 over 2 plus 3. It's equal to 0. So when it gets here, you remember what they taught you last year, and from grade 9, you can see that that is a trinomial. And how do we solve trinomials? Obviously, here we have to factorize. No one told you have to factorize, but you saw that the only way that you can solve for x here is by factorizing, right? And you remember the 3 steps of factorizing. That the first one is to find the common factors. The second one is to group terms, and you can only group terms if you have 4 terms or more. And the third and last step would be the difference of 2 squares, right? Difference of 2 squares. And then obviously the fourth one would be the difference of cubes, right? But we don't have a cube. We only use this one if the degree is maybe something like x cubed, right? But you can see that obviously we don't have common factors, and we can't group terms, because for you to group terms you need to have 4 terms, and we only have 1, 2, 3 terms. So we go to the difference of 2 squares, because we can't use this one because we don't have a cube, right? So we go to the difference of 2 squares, and we know that in difference of 2 squares, the first thing that you would do would be to open the brackets, right? The first thing would be to open the brackets. Then after opening the brackets, the next thing to do is this in standard form. Right? Remember that the standard form is the standard form is ax squared plus bx plus c. This is the standard form of each and every trinomial. This is the standard form, right? But in this case, we can see we don't have 2. The important thing is not the degrees we have, but you understand that we name them in descending. We write them in descending degrees. I repeat, we write them in descending degrees. So we know that 1 is greater than half, right? So the question then is, why didn't we start with 3? Because 3 is the constant, right? So we always end with it. We check the ones that have variables, and we check the variable that have the highest degree. We start with it. So we understand that 1 is higher than half. So this here is in its standard form. This is in its standard form. So it's fine written like that, right? I hope that makes sense. If it doesn't, the thing with you guys is that you don't get back to me. So I don't know whether you understand or not. I don't know whether you understand or not. Don't force to understand everything on your own, right? Ask me questions. No question is stupid. And the next thing would be to check the sign of the last term. Why do we have to write this thing in standard form? So that we ensure that the sign of the last term that we're checking is the correct one, right? So that is why we have to write it in its standard form. So we see that the sign of the last term is plus, and we know that positive tells us that the signs are the same. So the question is, which signs are the same? We check the sign of the middle term. So it's negative and negative. And if you don't remember this from grade 9, let me know, guys. From grade 10 and 9 to 9, let me know so that I can make a separate video that only deals with or specifically focuses on factorizing, right? So now that we know that the signs will be the same, and it will be negative and negative. Always, right? When you have a degree that is not a fraction, the first term, right? On the first term, you have a degree that is not a fraction, but then the second term, you have a degree that is a fraction. The wise thing to do would be to take the degree, to take the fraction of the second term and write it as it is. But always check afterwards. But most of the time it's like this, right? So we know that x half multiplied by x half, that will give you x to the power of 1, because the bases are the same, and add the exponents, right? I repeat, always when you have the first term that has a degree that is not a fraction, and the second term has a degree that is a fraction, most of the time, if not always, but I don't want to claim, so I'll say most of the time, you take the fraction of the second, the degree of the second term, and you write it as it is, right? You write it as it is, but after writing, check if it does give you the exponent of the first term. I hope I'm making sense. Then the last thing to do would be to find the factors of 3, and we know that the factors of 3 is only 3 and 1. And whether you put 1 this side, but the signs are the same, so it doesn't matter. So we just put 3 and put 1. This is still equal to 0. Let me erase everything so that I won't confuse you guys. So now that you see that we are here, it's easy to approach this. What I wanted to show you is that you don't have to be nearsighted, right? You don't have to put word clubs when you're doing maths. You have to think within the box first, think, and then go outside of the box, because here they mixed a set that will lead you to know how to solve equations, or when you're solving when you're given a trinomial. So it's sort of like mixed, right? But we'll be doing more of equations on the next chapter. So the next thing obviously here would be to say x to the power of 1 over 2 minus 3 is equal to 0, or x to the power of 1 over 2 minus 1 is equal to 0. And the next thing that we will be doing here is to see x to the power of half is equal to 3. And we understand that we have to multiply this by what? By 2 over 1. That would be the next step. So I'm writing here, which is what we did on the previous example. We are simplifying the exponents so that we're left with only one exponent. So 1 over 2 we multiply it with 2 over 1. What we do on this side, we must do on this side. So we multiply this with 2 over 1. We understand 2 over 1 is the same as 2. So this would be x is equal to, what is 3 to the power of 2? That is 9, right? Or x is equal to 1 of x to the power of half is equal to 1, right? And you understand also this one, we have to limit and multiplying by 2, right? So 1 of x to the power of 2 is the same as 1. 1 to the power of 2 is the same as 1. So those are the answers. X can be 9 or x is 1. So you have to check, always check, guys, because it might happen that only one factor is true, right? So you check. If they're both correct, you leave it as it is. But if only one is correct, then you would write something like x is an element of, use those brackets, x is an element of maybe, let's say, 9. So if you're written like this, you're simply telling the person who will be marking your paper that the only correct answer is 9. But if you don't write this, if they're both correct, you leave it as it is, right? So I hope that makes sense, guys. I hope that makes sense, right? So let me give you another form of this that you might get, right? So let's say, okay, we've been using x, let's use something else. Let's say you're told that p root p minus 2, and then the minus 3 again, then they tell you that that is equal to 0, and you are asked to solve for p, right? So the first thing to do, like any other approach that you would do, in this case, there's no obviously the variables on the left hand side, there's no coefficient that you can divide with, right? So I'm just trying to show you that you shouldn't be cramming one formula of how to approach these questions, right? So the first thing to do obviously would be to take this to the other side. So we will be left with root p minus 2, and then we'll be having 3, right? So from here, the wise thing to do, obviously, you can't force to write this as a fraction, but you can write it in this form, right? You can write it in that form, right? But that would not be the wise thing to do. Would just be complicating things, right? So from here, what you can do is simply take this side and square it. Why are we squaring it? Because there's invisible 2. We understand that if we say 8 root 8 multiplied by root 8, we understand that the answer will be 8. So it's like when you're multiplying the roots with the same that have the same degrees, we are simply eliminating them and returning what they have inside as it is. I hope I'm making sense and I'm not confusing you guys. It's very, very simple. It's very, very, very easy. Right? So what you do on the left hand side, you must do on the right hand side. So you take this to the power of 2. So we understand that this would be p minus 2. Right? You don't need a calculator for this, it wouldn't even give you, right? So you understand that the reason why we are writing this, because this squared simply means like we are eliminating the roots, right? Then this would be 9, right? And from here, obviously, this is like the simplest form of solving for x. So this would be 9 plus 2. When this goes to, let's say, the changes side. So this would be 11. So you take that 11 and put it there and check if it's correct. So 11 minus 2 is 9, right? So it's root 9 minus 3. That should give us 0. So root 9, we understand the square root of 9 is 3 minus 3, that is 0. So the left hand side is equal to the right hand side. So it means we are correct, right? We are correct. But there's something I forgot here, and I hope you see and you can tell what is it that I did wrong. Remember that always when you're removing the square, it should be plus minus, right? So here it should be plus minus, right? But this would be useless because I'm only concerned with this here, right? I'm working with this, right? I hope that makes sense, guys. I hope that makes sense. So let me give you maybe one more example, and then we try. I give you exercises and then we move on to the next chapter. This video is quick, you can finish it now, today. Let me know, then you can get another video later on. Sorry for taking time, I had things to do. I'm always busy, but I'll always make time for you guys. So you're given something like that, and you're told that that is 0, right? So how do you approach this one then? How do you approach this one? This, more of these ones will be doing in the next chapter, but this is also it's important that we do it now, right? So how do you approach this kind of questions? Obviously, the first thing to do would be to take this to the other side. So we'll be left with 2 to the power of x plus 1 is equal to 32, right? So here you get your first mark, understanding that this is to go to the right side. The variables have to be left to on that side, because then the next thing to do is to ensure that this is the same base as this one, right? So it will be 2. If you take your calculator, write 32, press equal to shift, press the button which has fact on top. That is only when you're using keys. So obviously the bases will cancel, and then we'll be left with x plus 1, it's equal to 5. So 5 minus 1 x will be equal to 4. It's that simple. It's that simple. It's that simple. So I want you to solve this one for me, guys. When I say solve things, please solve them. Please solve them. It's for your benefit. Otherwise, you end up seeing this in your exam or test and then you'll be saying that I didn't teach you. So if you want to get 100%, you have to do essentially 3y to the power of quarter plus 1 is equal to 0. So this is the first one that I want you to do for me. Solve for y then. The second one that I want you to do for me is t minus 1 is equal to root 7 minus t. So you solve for t. Right? The third one that I want you to do for me is x to the power of 1 over 3 open bracket x to the power of 1 over 3 plus 1. All of this is equal to 6. And then the fourth one that I want you to do for me is 2 to the power of 4n minus 1 all over the fourth root of 16. And that should be equal to 0. And the fifth one that I want you to do for me is y minus 10 root of y plus 9 is equal to 0. Don't ask anyone for help. If it gives you problems, let me know, right? If it gives you problems, let me know. That will be all for now. So pause the video, write this down as they are, and solve them and let me know. Start with the one I give you. Start with that one that we have to solve from the previous lesson, the one of x and what, right? Start with that one. Start with this one. I think it was about 5x's. Start with that one before coming. You let me know if you have problems so that we move on to the next chapter, because the next chapter we'll be completing the square, we'll be using the quadratic formula, we'll be substituting and finding the equations, we'll be doing the nature of roots, quadratic inequalities, continuous equations, word problems, and that will conclude the next chapter. Right, so I want us to move fast, but we cannot move fast if you don't understand. Right, so tell me as soon as you're done with that, and I'll always make time for you each day to make in other videos. And I didn't forget you with physics, so let me know if the PDF I sent you, because remember with physics I once told you that we have to do it with the protractor. So I don't have a protractor with me here, and I didn't do a lesson on that one. So I sent you a PDF that summarizes how you approach that. So let me know if you did understand that PDF, and if not, what is it that you didn't understand, so that I think now that you have read that PDF, it will be easier for me to explain, even if I don't have a protractor, right? It will be easier for me to explain. So I hope that makes sense, guys. Watch the video. If you didn't understand something, watch it again. And then if you still don't understand, then get back to me as soon as possible. Don't watch a video today and finish it and understand, and then you tell me next week that you've done the video, because that will not favor us in terms of finishing the work in time, right? So that's it from me, guys. Take care of yourselves.